Let's study yield curve, or also known as term structure of interest rates. And it is always good to start with a simple numerical example. So suppose today is 1st of September and there are 5 government bonds available in the market. 1-year bond, 2-year bond, 3-year bond, 4-year bond, and 5-year bond. So the 1-year bond pays you £100 in 1 year, and current price of that bond is £98. The 2-year bond pays you £100 in 2-year period, and its price is currently £96 and so on. So they are all discount bonds. There are no intermediate coupon payments. You have to wait until the maturity to get cash. For this reason, they are also called zero coupon bonds. So discount bonds and zero coupon bonds are the same thing. Now, what are the interest rates implied by the prices of these discount bonds or zero coupon bonds? These are the interest rates or yields implied by these prices. The yield of the 1-year bond is 2.04%. The yield or the interest rate implied by the price of the 2-year bond is 2.06%, and so on. How do we compute this? Well, we studied that math in a previous class on basic interest rate calculus, but let me give you a short recap. Let's see, for example, the 1-year bond. Today's price is 98, so 98 times 1 plus unknown interest rate I should be equal to 100, because £100 will be paid in 1 year. So 1 plus I is equal to 100 over 98. I is equal to 0.0204, 2.04%. Let's see the 3-year bond. Annual interest rate implied by the price of the 3-year bond. Current price is 93. So 93 times 1 plus unknown interest rate to the power 3 should be equal to 100. So if you divide both hands by 93, 1 plus I to the power 3 is equal to 100 over 93. And if you take the third root of both hands, 1 plus I is equal to 100 over 93 to the power 1/3. I is equal to 0.0245, 2.45%. Same for other bonds. As you can see in this example, annual interest rates implied by 1-year, 2-year, 3-year, 4-year, and 5-year bond prices are moderately upward or moderately increasing in time to maturity. These 5 numbers are the term structure of interest rates in this numerical example. So the term structure of interest rates are the implied annual interest rates as a function of time to maturity. So from the government's point of view, 2.04% is the interest rate, annual interest rate to borrow money for 1 year. 2.06% is the annual interest rate to borrow money for 2 years. 3.06% is the annual interest rate to borrow money for 5 years. And in this numerical example, the term structure of interest rates is upward sloping. Now suppose that the prices of these bonds have changed. Yesterday, the prices were 98, 96, 93, 1986. The same numerical examples as in the previous slide, and accordingly we computed the term structure of interest rates. Suppose today the prices have changed. Now the 1-year bond costs £99, so the price increased. 5-year bond costs only £80, so the price dropped. Again, you can compute the interest rates implied by these new prices. Now, the annual interest rate implied by the price of the one-year bond is lower than the previous one. The annual interest rate implied by the price of the 5-year bond is much higher than the previous level. Here, I think it is good to remember what we learned in a previous class about the relation between the bond price and the implied interest rate. The bond price rising is equivalent to the implied interest rate dropping. And the bond price dropping is equivalent to the implied interest rate or yield rising. Okay? As a result, the term structure of interest rates is steeper, even more strongly increasing in time to maturity than yesterday. Let's call this price change scenario A, and let's consider a different scenario, scenario B. In scenario B, the prices of shorter bonds fall and the prices of longer bonds go up. As a result, the prices of shorter bonds and longer bonds are very close. By the way, these are discount bonds or zero coupon bonds, and for zero coupon bonds, it is always the case that shorter bonds are more expensive than longer bonds, and longer bonds are always cheaper than shorter bonds. And the reason is because if you buy shorter bonds, like one-year bond, you can get £100 in 1 year. You have to wait only for 1 year. With a longer bond, like the 5-year bond, you have to wait for 5 years to get £100. The shorter the waiting time is, the better, and therefore the shorter bonds are always more expensive than the longer bonds. But sometimes the price difference between shorter bonds and longer bonds are very large, as in scenario A. Sometimes that price difference is very small, as in scenario B. When the price difference between shorter bonds and longer bonds are very small, if you compute implied interest rates implied by the prices, shorter bonds imply very high annual interest rates and longer bonds imply relatively low annual interest rates. And as a result, the term structure of interest rates is downward sloping. Let's plot these term structure of interest rates in a diagram. In this slide, the upper half of the slide is exactly the same as the last slide. I just repeated it for convenience. And we are going to plot these term structures in a figure. So this figure plots the term structures we've just computed. The horizontal axis is time to maturity, years to maturity. We have 1, 2, 3, 4, 5-year bonds. And the vertical axis is the implied interest rates implied by the prices of these bonds. For the initial set of bond prices, as we computed, the term structure of interest rates is moderately upward sloping, as is depicted in this blue line. After the price changes, as in scenario A, the term structure is now more strongly upward sloping. In scenario B, the prices of short bonds and long bonds are pretty much close, and in such a situation, the calculated term structure of interest rates show a downward sloping curve. When the term structure of interest rates are depicted in a figure as a curve, it's called yield curve. So yield curve and the term structure of interest rates are the same thing. When the yield curve is downward sloping, it is called an inverted yield curve, meaning that the longer term bonds are not much cheaper compared with shorter term bonds. So prices are pretty much similar. You can compute yield curves or term structure of interest rates for any government bonds, not just UK government bonds. You can compute them for German government bonds or Greek government bonds or US government bonds, etc. You can calculate yield curves for corporate bonds as well, for AAA firms, AA firms, BBB firms, and etc. The level of yield curve should be higher for riskier category than for safer category. So, for example, it is likely that the yield curve for Greek government bonds should be above the yield curve for German government bonds. And this is because, remember, high prices of bonds imply low interest rates. And for the same face value 100 euros, it is likely that German government bonds are more expensive than Greek government bonds because they are safer. Finally, yield curves of different governments and institutions have different levels, but sometimes they have similar shapes or slopes. And for this reason, even if you are interested in corporate bonds, still the yield curve of government bonds is informative because the slope or shape of the curve can be similar.